Let's check this sheet out. Geometrical optics. We'll close geometrical optics with this sheet and then move on to electrostats after this, right? I have to again honestly confess that there is still many more problems that we could do in the class, but you know, there is always a constraint of time which prevents us, which therefore, you know, I would assume that you would practice at home enough to cover for that, right? So let's examine the first problem of the sheet. So we have a system of two lenses with their principal axis separated. This is the principal axis of this lens, call it PA1. Also the x-axis of the coordinate system. The optical center of this as the origin of coordinates, right? And we have another lens whose principal axis is this. PA2. This is principal axis of lens 1. And the principal axis separated by a distance delta. Separated by a distance delta, right? The magnitude of the focal lengths of the two converging lenses is given to be f1 and f2. And the separation, horizontal separation between them is given to be d. And it's also mentioned that this d is bigger than f1 plus f2. This is the y-axis. I then want to find, with this as the origin and this as the coordinate system, I want to be able to find the coordinates of the focus of this pair of lenses. This is what we want to be able to do, right? It's a very simple problem, really. Essentially, what we are seeking is, if there is a beam incident parallel to the principal axis, then having suffered two refractions, once here and once there, where would this beam settle? That would be looked upon as the focus of this system. As simple as that. Now, this beam parallel to this principal axis, after refraction from this, would settle at f1 units. F1 is the focus of focal length of this, would settle at f1 units from this. This then would serve as an object for a second refraction by this, right? Now, what you could do is this O1 serving as an object for second refraction, could be looked upon as an extended object, say AO1 referred, see this is the principal axis of the second lens. So you would rather want to deal with AO1, which is an extended object, right? Of size delta, and of object distance from the second lens equal to d minus f1, the object distance. Clear? Very refreshing to see you guys sitting in the front. Now, with this object distance, with u as d minus f1, and refraction occurring from this converging lens of focal length f2, let me find out the image distance v. For object distance d minus f1, right? So for second lens, object distance is d minus f1. Focal length is minus f2. f2 is the magnitude of the focal length, but the focus of this lies on this side. So f is minus f2. So 1 by v is 1 by u, which is d minus f1 minus 1 by f2. Minus 1 by f2, yes or no? Prince, lost kya? 1 by v minus 1 by u is minus 1 by f2. F is minus f2 here. Clear? Okay. So then this makes v equal to d minus f1 into f2 divided by f2 plus f1 minus d. V turns out to be negative. See, d minus f1 is a positive number, f2 is a positive number, but f1 plus f2 minus d is a negative number. V is negative. That means a real image is formed in this case. The image is formed on this side. The image is formed on this side. And if it is formed on this side, realize that if this is the optical center of this, a ray of light from O1, see, the image of A will be formed somewhere here only, right? At this distance. The image of O1, for example, you know, if you look at a ray of light passing through the optical center of this lens, it will go undeviated. So the image of O1 would be above the principal axis of the second lens. Have I communicated myself properly? Right? That means A lies on the principal axis, image of A will lie on the principal axis, image of O1 will lie above this principal axis. Yes or no? Which means, yeah. So image of A is, say, A1, A prime, and image of O1 is, say, O1 prime. And V is negative for this object, for this image. So on this side of the lens, clear? Now, in my scheme of things, I would always look upon magnification as a magnitude, right? I would not draw clue from the sign that comes out of so we would always look upon magnification as mod V by mod U, right? So magnification produced by this system is mod V divided by mod U. Mod U is the same as U because U is positive. And do you realize this is U? D minus F1 is U. D minus F1 is U. So do you realize that V by U, V divided by U is F2 by F1 plus F2 minus D? Yes or no? Mod of this would be F2 divided by D minus F1 plus F2. Do you realize that? Mod of this would be F2 divided by D minus F1 plus F2 because this is a negative number, right? So then mod V by mod U is like F2 divided by F1 D minus F1 plus F2. Tell me, do you register this right? Mod V by mod U. I take the mod of this. Mod of F2 would be F2. Mod of this would be D minus F1 plus F2. Why? Because F1 plus F2 minus D is a negative number. So mod of the D, mod of this would be negative of this. Clear? Right now? Now, the size of the object, if AO1 is looked upon as an extended object, the size of the object is delta. This separation. The size of the image would be m times delta, would be m times delta. So the size of this image is going to be m times delta. Delta is known to us. M has been obtained. M has been obtained, so I know the size, yes or no? Confused? No. Okay. So we are all set. We are all set. This distance, say O prime, this distance would be mod V, yes or no? Because V is negative, this image distance would be mod V, would be mod V. So then let's finally write down the Eventually, whose image are we seeking? The image of O1. That means O1 prime. We are seeking the coordinates of O1 prime. So for O1 prime, the x coordinate is going to be D plus mod V. D plus mod V, yes or no? Right? And mod V would be D minus F1 into F2 divided by, right, D minus F1 plus F2. Good. That's the x coordinate of O1 prime. D, this distance, plus mod V. Mod V is this. V was this, so mod V would be change of sign of this. The y coordinate of O1 prime is going to be delta plus m delta, right? That will be the y coordinate. Delta plus m delta would be the y coordinate of O1 prime. So the y coordinate of O1 prime is going to be delta into 1 plus m. Delta is known, m we have computed from these considerations. So this would be the coordinates of the focus of this pair of lenses, system of lenses. Right? Sounds good? How many of you did this right? Prakhar, Abhishek, right, Tiash, right, Tiash. Right? Let's look at the next problem then. A beam of light converges to a point on a screen. Okay. This is a screen S. And say there is a beam of light that converges to this point. There is a beam of light that converges to a certain point, say P on the screen. Clear? If a lens is placed in the path of the beam 10 centimeters from the screen, why is it after me all the time? There's so many of you around, but 10 centimeters from the screen there is a lens. I do not know whether it's a concave lens or a convex lens, so I just put a dotted line. It's a lens, some device here, 10 centimeters from this, right? Given this, the screen has to be moved 8 centimeters to obtain a sharp image. Now, that 8 centimeters movement of the screen could be in this direction or could be in this direction, right? Could be in this direction or in this direction. If it's a diverging lens, then it will diverge the beam and the screen would have to be moved rightwards. If it's a diverging lens, then it will diverge this beam and it will move to, the screen would have to be moved to this position S prime. The screen would have to be moved to this position S prime, and this is how it gets refracted through the lens and gets diverged to this point, say Q, where Q becomes the image of P. Can you tell me, for this lens, this is the virtual object and this is its image, right? Do you all understand this? If the lens was not there, it would have gone there. So this would serve as an object for Q. Q is the image where P is the virtual object. This is a virtual object because this ray of light never converged to this point. Prematurely it got refracted in the lens here and converged to Q. P therefore is a virtual object for refraction at the lens, and for a final image Q. So then, if this is the optical center of this lens L, this is a diverging lens then. That means its focal length should turn out to be positive. Its focal length should turn out to be positive, yes or no? Right? Let's check. So now, for this case that I have discussed, u is minus 10 centimeters, yes or no? From the lens, distance measured in the same direction as the incident ray, negative, u as minus 10 centimeters, right? And what is v? Minus 18 centimeters. Right? So 1 by f is going to be 1 by v minus 1 by u, which is minus 1 by 18 plus 1 by 10. Right? Do you all understand this? Clear? If it's so, then in this case, this obviously is a positive number. As you can see, f can be obtained from this. And if it's a positive number, that means this must be a concave lens. That means it must have been a concave lens, a diverging lens in character. Yes or no? Right? If the lens had to be shifted rightwards. Right? Clear? So this is possibility 1. Let me look at possibility 2, where the screen had to be moved leftwards by 8 centimeters. To get a final image to the left of P. Q would be to the left of P then. Right? That's a second possibility. Can I just wipe this portion off? Right? So case 2. Struggle here. So, now the screen is moved here. This is the screen S prime. The ray does not go all the way there. Because of this lens, it converges to this point Q. This must be a converging lens and its focal length must turn out to be negative. And if it's moved 8 centimeters here, then Q becomes the final image and P the virtual object. And Q will be the final image. This must be a converging lens. Its focal length must turn out to be negative. Right? So for this situation, what is U? Minus 10, same thing, minus 10. V is, this is 2 centimeters, so minus 2, measured in the same direction as the incident ray. This is 2 centimeters. And then focal length would be 1 by V minus 1 by U, which is a negative number, as you can see. You expected this to happen. It's a converging device. So focal length must be negative. This must be a convex mirror then. Clear? Okay. How many of you got this right? 1. Okay. But I hope all of you have understood this properly. Right? No confusion on this? Right? Let's look at the next one. Right? Prince, have you understood this? Can I wipe this off? An object of height 4 centimeters is kept to the left of and on the axis of a converging lens of focal length 10 centimeters at a distance 15 centimeters from the lens. Converging lens, focal length 10 means minus 10 centimeters, right? This is the principal axis of the lens. there is an object of height 4 centimeters, AB, kept at a distance of 15 centimeters from the lens. Right? Now, if the mirror was not there, let's figure out where the image would be formed. The size of the image, the position of the image, etc. Right? So I'm going to use U is 15 centimeters. 1 by V would be 1 by 15 minus 1 by 10 minus 1 by 30. That means a real image on that side would have been formed. V equal to minus 30 centimeters. Right? And magnification is 2, 30 by 15. That means size of the image must be 8 centimeters. Size of the image must be 8 centimeters. So image size must be 8 centimeters. Because magnification is 2, size of the object is 4 centimeters. Clear? Yeah. Okay. Now, again, to know whether the image is going to be inverted or erect, all that you do is, well, the image of A will be formed 30 centimeters to the right on the principal axis. As far as B is concerned, look at a ray that passes through the optical center. It will go undeviated. Eight centimeters. So the image of B must be formed below the principal axis, because if you look at a ray like this, which passes through the optical center, it will go undeviated. So for sure, the image would be formed. No part of this ray lies above the principal axis to the right. And therefore the image of B must be formed somewhere here, let's say at B prime. A prime, B prime. And this separation is 30 centimeters. This separation is 30 centimeters, yes or no? Right? Now, look. 10 centimeters from the lens, a plane mirror is placed 45 degrees with respect to the principal axis. Okay. Plane mirror at 45 degrees with the principal axis, 10 centimeters from the lens. This must therefore be 20 centimeters. Right? Now, see, rays of light going this way to converge at B will get prematurely reflected here. And instead of converging at B prime, they would converge at some other point, B double prime, say? Yes or no? Which means A prime, B prime will be a virtual object for reflection on the mirror? Yes or no? A prime, B prime would be a virtual object for reflection on the mirror, yes or no? Yes, sir. Okay, now the point is, I want to see the orientation of the final image, the size of the final image. Now see, size of the final image would be 8 centimeters only, because the plane mirror will not change the size of the object. Size of the object is, even though it's a virtual object, the size is 8 centimeters of the object, the size of the image will also be 8 centimeters. Right? But now, it would be important for us to examine how exactly the formation would take place. Right? Since I have drawn the figure so big, I will just draw it a little more condensed so that I can have room to write more. So I'll just, you keep this intact with yourself. I'll just redraw this to create more room for myself to be able to tell you what exactly happens. Right? Can I wipe this off? With this as the virtual object, I want to find the image, which is going to be a real image. If the object is virtual in a plane mirror, the image will be a real image, right? So it's going to be formed somewhere here, right? So I'll just maintain in the figure whatever is required. Other things I'll remove. See, this was the optical center of the lens. This was the optical center of the lens, right? This was an object, say A prime, O prime was the object. Or have I called this A there? Okay, I've called this B. So let me call it B prime then. Okay, which is a 8 centimeter object. 8 centimeter object. Clear? Now, and this separation is 30 centimeters, right? Now 10 centimeters from this, if I had placed a mirror vertically, right, then its image would be like this only, would be vertically downwards. A double prime, B double prime would have been like this. Forget this for a while. Would have been A double prime, B double prime like this, say. Would have been its image. A double prime, B double prime. If this was 20 centimeters, this would have been 20 centimeters if this was vertical, right? Now the point is, if the mirror is rotated by an angle theta, the reflected rays will rotate by an angle 2 theta. If the reflected rays rotate by an angle 2 theta, the image will also rotate by 2 theta. That means if this object is vertical, if the mirror is rotated by 45 degrees, its image will rotate by 90 degrees, the image will be horizontal. The image will be horizontal. Yes or no? Do you all understand this fact? Purohit? Which means, now, if this was the mirror, rotated by 45 degrees, then the image, which was originally like this, would rotate by 90 degrees. And, say if this is the object A prime, realize its image on the plane mirror would be A double prime like this, such that object distance is equal to image distance, right? And this was 20 centimeters, right? Right? The image of A prime would be A double prime, and since now the final image is horizontal, can I say that the final image must have been like this, B double prime this way? Yes or no? What do you say? The image must, see, the image of B prime would be B double prime like this, and the image which was vertical now has become horizontal, has got rotated by 90 degrees because the mirror got rotated by 45 degrees, right? Clear? If this was 8 centimeters, this would be 8 centimeters, right? Now, this is 45 degrees, right? This would be 20 by root 2 means 10 root 2, right? This would also be 10 root 2, right? This would also be, right? Object distance is image distance. Realize that this is also 45 degrees, and this, because see, now it's all in place. This is 20 centimeters. This is 45 degrees. This is 20 root 2. This is 20 root 2. So this vertical distance must be 20. This vertical distance must be 20, right? But to maintain this angle 45 degrees. So the image is formed like at this position 20 centimeters, right? This is 20 root 2 sine 45 degrees. Yes or no? Clear? So once you know where A double prime is located, then 8 centimeters in this direction would be where B double prime would be located. Do you understand this very clearly? No, we will assume that this is the final image. There would be rays that would intercept, and there can be a final image, but we'll assume this is the final image. If you want to look at the final image, then this would act as a virtual object for second refraction from the lens, and that would be the image. For this problem, we will stay confined to this as the final image. Make sense to all of you, right? Let's look at the next problem. The next problem is an easy problem but has a terse language. The next problem has a very terse language. Let me simplify the language of the problem first, right? The cone has has an apex angle, right? All of you understand this? This is a cone, and it has an apex angle, A, right? You also understand that this is the axis of the cone, right? What we want to be able to do is, we want to be able to model the angle, apex angle of the cone. We want to be able to model the apex angle of the cone such that if we had placed an object O on the axis, such that if we had placed an object O on the axis of the lens, then if there is a ray of light which got reflected, see, the inner surface is reflecting surface. The inner surface, if it had got reflected from the first surface, it would never seek reflection on the second surface. It would get reflected only on one of the two surfaces. If it gets reflected here, it will not get reflected on this. So we have to, principally you would understand that, if I start to open up the apex angle, then this can become a possibility. For example, the worst case is what? A cone with an open angle like this, A. I open it up completely. Then on placing an object O here, right, when the apex angle becomes 180 degrees, then if there is a ray of light, it will get reflected. No scope of reflection on the second surface of the cone. Which is what I'll tell you, show you. It will not depend on the position of O, which is what I'm going to demonstrate. In this case, does it depend on the position of O? If O is symmetrically placed here, will it depend? So this is an extreme case, just to make the assertion look believable, right? But the point is, how much should you open? Of course, if you open by 180 degrees, you know that this is going to happen. But then, you don't want to disturb the status of the cone. You want to maintain it conical. You want to open it to such a degree that, beyond that, it will not get reflected a second time from the conical surface. This is what you want to do. But before that, let me tell you one very basic simple thing. What I would imagine is, I would imagine this entire thing to be equivalent to two plane mirrors and inclined at a certain angle A, and on the angle bisector between the two plane mirrors, I place an object O. I want to model the angle A of the cone such that a second reflection doesn't occur for any object O placed on the angle bisector at A. This is what I want to do. That's an equivalent. No, no. Only the curved surface we would imagine. Yes. Clear? Now, a simple idea first, which I want to tell you. A very simple idea. Very simple notion first. For convenience, let me take an inverted cone. It'll be easier for me to draw that. That's why. Okay. Inverted, or rather two plane mirrors placed this way. Two plane mirrors placed this way. And this is the angle bisector between the two plane mirrors. Outer surface silvered. Right? Say this is mirror 1, M1, this is mirror 2, M2. Right? Say there is an object O. There is an object O placed on the angle bisector. Clear? Do you realize that it will have, if it undergoes reflection here, an image of O would be formed at I, such that object distance is image distance, yes or no? And this can be obtained by any two reflected rays, can be used towards constitution of this eye. How about it? Now, essentially, in this case, what really happens is, I can think of a reflected ray passing through eye and being intercepted by this mirror. See, for example, there could have been a reflected ray like this, which when any reflected ray when produced will pass through eye. That's why this eye is formed. Any reflected ray when produced will pass through the image of this object. Yes or no? Right? And this would be a reflected ray for this being an incident ray. This would have been a reflected ray for this, an incident ray. Right? Now, realize that if there is a ray which this can conceive, passing through eye, if I can conceive of a ray, reflected ray, incident on this, which passes through eye, then a second reflection occurs. Then a second reflection will certainly occur. If I can conceive of a reflected ray, I repeat, if I can conceive of a reflected ray, which is incident on this, passing through eye, then a second reflection is bound to occur. So for our internal consumption, I say that this mirror is able to see eye. Eye is visible to this mirror. And as long as eye is visible to this mirror, a second reflection will occur. That means, see, this will happen as long as this reflecting surface, the image of eye is above this reflecting surface, then it will be able to see eye, yes or no? Do you realize that? See, this is the surface. Imagine this to be the entire surface. As long as the image of O, which is eye, is above this dotted line, see, above this entire thing, M2, right? Then I can think of a reflected ray passing through eye and incident on this, yes or no? Yes, sir. So when would eye be visible to this mirror? Eye would be visible to this mirror as long as eye is above this M2. Behind M to hoga yaar. Image of M1, image of O will obviously be behind M1. It has to be behind M1, but as long as it's above this, it is visible to this mirror. And if it is visible to this mirror, then a second reflection is certain to occur on mirror M2. Yes, I will. See, forget everything. All that I'm saying is, I can a second reflection will occur if I can think of a reflected ray incident on this that passes through I. And when will that happen? That will happen if I is above this. That means the image of O, which is I, is above this. Then I can think of a line passing through I and incident on this, which would be like a reflected ray on this. That's when I say I is visible to this mirror. Right? But suppose, Socho, if the image of O was formed here, if the image of O was formed here, then can you think of a ray which passes through I and is incident on this? Can you see, suppose the image of O was formed here, below this line, below this mirror M2. Then can you imagine a reflected ray passing through I and incident on this mirror? Because every reflected ray from the first surface must necessarily pass through I. So all the reflected rays in view would be those that pass through I. Now can you create a reflected ray? If the image of O were to be formed here, can you create a reflected ray that passes through I and is incident on M2? No. Bojachi. If the image of O was formed here, can you imagine a reflected ray from the first surface, reflected from the first surface, that passes through I and is incident on this? Can you draw one ray? Reflected from the first surface, has to pass through I also and is incident on this? Can you do that? If the image was here? No. That means there isn't. Right? There isn't a reflected ray from this surface which passes through I. And I mean, all reflected rays from the first surface have to pass through I. Right? But now can I think of any reflected ray, even one reflected ray which passes through I and is incident on M2? I can't. But if I was above this line, so in this case we say I is not visible to this mirror M2. In this case we say I is visible to this mirror M2. It will depend. Okay, then give me a few more minutes to justify my proposition that it will not depend on the position of the object. Right? Just give me a few minutes. We will have a geometrical proof of it. I will not say things in the air. Right? Just one thing for sure, it will not depend on O. I mean, if this can happen for one O on the axis, it will happen for all O's on the axis. This is what I am telling you, which is what I am going to show you. Right? Such has to be the angle. Now, so if this happens, if the image of O is visible to this, a second reflection will occur from this. If the image of O is here and is not visible to M2, a second reflection will not occur. In the first place, has this thought settled in you? Now, let me redraw the mirrors, proposing the idea better with a better diagram. I like to draw it like this then. The two mirrors. Mirror M1, mirror M2. This is the angle bisector at A. This is the angle bisector at A. If this is alpha by 2, let's say, this is also alpha by 2. Right? What I want is, if there is an object O here, this is the object distance, reflection from M1. This is the object distance. What I want is the image of O to be below M2 so that it is not visible to M2 and will therefore prevent a second reflection from M2, right? I want the image of O to be below M2. Then I can't think of a reflected ray which passes through I and is incident on M2, isn't it? Because all reflected rays from this surface must pass through I, and they would, in this case, no reflected ray passing through I will be incident on M2. Yes or no? Right? Say this point is M. This should be the geometry involved. This should be the geometry involved. Image of O must be formed below this line of M2 so that this is not visible to M2 and will prevent a second reflection from the conical surface, which is from M2. Right? Are you concerned? No? Now if I look at this diagram, do you realize this angle is alpha by 2? Object distance is image distance. This is 90 degrees, 90 degrees common. These two triangles are congruent, right? So can I say that this angle must also be alpha by 2? Right? From these two triangles are congruent. Object distance, image distance, 90 degrees, side common, right? So if this was alpha by 2, which it is, then this angle IAM will also be alpha by 2. So if this was alpha by 2, this is alpha by 2, then this angle will also be alpha by 2, right? And the only requirement is that alpha by 2 plus alpha by 2 plus alpha by 2 must be greater than 180 degrees. In order that I is below this plus this must be greater than 180 degrees. Yes or no? So 3 alpha by 2 must be greater than or equal to pi. Limiting case. So alpha must be greater than or equal to 2 pi by 3, which is 120 degrees. Where is it depending on the position of the object? If this turns out to be greater than 120 degrees, then the image of O will always be below this, such that these angles add up to more than 180 degrees. Right? So minimum alpha for which this can happen is 120 degrees. So anything 120 or more will prevent a second reflection from the cone. Clear? No, it's not. Every generator of the cone will be like a line, isn't it? Which will be a reflecting line, which is like a plane mirror only. Isn't it?
I did not properly understand why if it is below the M2 surface it will...
Okay. See, think of it like this, Kushal. This is M2, right? This is M2. All reflected rays that get reflected from M1 will pass through I, right? Suppose I was here, right? What we want? We want reflected rays from this to not be incident. Now, can you tell me, can you even draw a single reflected ray? This was M1. Can you draw a single, all reflected rays will pass through I. Can you draw a reflected ray passing through I and is incident on M2 if I is below this? Nahi na? Isn't it? Yes. That's when I say I is not visible to M2, because no reflected ray from this will ever be incident on this. All reflected rays must necessarily pass through I. No reflected ray would be incident on M2. Right? If I is below M2, because all reflected rays have to pass through I. Right? All right then, number 5. There is a medium here with mu equal to root 2. There is a medium here with mu equal to root 3. And this surface between the two media, this region between the two media is mu equal to 2. Right? We are then talking of rays of light incident on AB. We are then talking of rays of light incident on AB. Such that there is total internal reflection here as well as here. What must be the minimum angle of incidence, say theta here, such that it gets totally internally reflected here as well as here. This is what we are trying to do here, right? Now, say this was 1, medium 2, medium 3. So, what is the critical angle between 1 and 2? What is the critical angle between 1 and 2? Sin theta 1, critical angle between this, right? Denser to rarer medium, denser to rarer medium, it will bend away from the normal, would be 1 by root 2, isn't it? Root 2 divided by 2, 1 by root 2. So, critical angle for 1, 2 is 45 degrees. Right? Critical angle for 1, 3. Root 3 by 2. Yes or no? This is root 3, this is 2. 1 by sin theta c is what? 1 by mu of the denser medium with respect to the rarer medium. Denser medium is 2. That means mu of the denser medium 2 divided by mu of the rarer medium, which is root 3. Again, I don't think this way. This is not how I think. If I have to find the critical angle, I'll just think smaller by larger. Because sine would always have to be less than 1. So I'll just think smaller. I never thought all that when I wrote this expression. I just thought I have to make this right hand side less than 1. It couldn't have been 2 by root 2. It must have been root 2 by 2. If I have to find the critical angle between these two, obviously it can't be 2 by root 3. It has to be root 3 by 2. That's all. Isn't it? Don't think of the formulas every time. Okay? Got me? So in this case, critical angle for 1, 3 is 60 degrees. Yes or no? Yes. Right? Now, so for this medium and this medium, critical angle 45 degrees. For this medium and this medium, critical angle 60 degrees. Right? Now, there is a reflection that occurs here. If this is theta, this must be theta. And then, this is also theta. So this will be theta. Yes or no? That means, do you realize the geometry here? So theta has to be greater than 45 degrees here. But theta here has to be greater than 60 degrees here. That means theta has to be greater than the larger of 45 and 60 degrees. It has to be greater than the larger of 45 and 60 degrees. So theta has to be bigger than 60 degrees. I mean, if I chose a theta between 45 and 60, say 48 degrees, it will get totally internally reflected here, but will get refracted here. But if theta is more than 60 degrees, it's certainly getting reflected here and also here because it's greater than 45 degrees. Yes or no? right? Hey, you missed the last class. Why? Huh? No, you I know. Oh, very good. 8 o'clock. Why did you miss the last class? Fever? Are you okay now? Don't miss the next few classes, because next few classes I'm going to start new topics. And if you miss the foundation of calculus, the foundation of electrostatics, you're done. Okay? Don't miss classes. Okay, that's 5. Shall we move to the next problem? Hello? Where? Huh.
So, will it also not go into air?
No. I'm talking of incidence between 1 and 2 and 1 and 3 only. Where is air?
No.
After reflection. वो ठीक है. I mean, see, nothing is given, whether it's air or what it is. I mean, we will assume that the entire intervening medium between the two layers is mu equal to root 2. Yes, very large. Very large is what we'll assume in absence of data. Right? A point source is placed in a tank filled with a liquid of refractive index root 2 at its bottom. This is the surface. This contains mu equal to root 2. This is air. Point source O placed here. It starts to move up. It starts to move up with a velocity 1 meter per second. What will be the rate of change of visible area at the surface when the source is, this is the source, is 2 meters from the upper surface of the liquid? First of all, it is important to understand the visible area. Visible area. Right. Eventually, see, this is an extreme ray, and this will be theta c between the pair of media, and it will graze on the surface. Similarly, this is another extreme ray. This is theta c, and it will graze on this surface. Right? If you take rays after this, they'll get totally internally reflected, and that part of the surface will not be visible to O. Yes or no? Rays within these two extremes will have theta less than theta c and will be visible. Right? Which means, you know, if you think of it three-dimensionally, this will be like a cone. This will be like a cone whose base area is this and is the visible area. This is the visible area, which is the base of this cone with vertex O. Right? So if this is R and this is H, and if this is theta C, obviously this will also be theta C, where sine theta C is 1 by root 2. Don't think of the formula at all. Okay, theta C is 45 degrees, right? The visible area at any given instant, at an intermediate instant, visible area A is pi r squared, is the visible area. This is the visible area. Beyond that, there is total internal reflection, right? The base of this cone is the visible area. After that, rays will get totally internally reflected, right? Now, in terms of H, realize that R is H tan theta. R is H tan theta. Tan squared theta C. But tan theta C would be 1 because theta is 45 degrees. Theta C is 45 degrees. So tan theta C would be 1. So this would be pi h squared. Right. dA dt is what we are seeking. 2 pi h dH dt. 1, absolutely. dH dt is the velocity of the source upwards, which is in magnitude 1 meter per second. So this would be 2 pi h into 1. dH dt is 1, and at h equal to how much? At h equal to 2. For h equal to 2, this will become 4 pi. 4 pi meter squared per second is the rate at which the area is visible, minus magnitude of the rate at which area changes. Magnitude. So if you want me to be very particular about this, yes, otherwise you are right, Prakar. dH dt, h is decreasing with time, so dH dt should be minus 1. Yes, I agree with you. So let me just be technically correct, mod dH dt. No, theta will change, but theta C will not change, isn't it? Hone do? Yeah, that will change. The vision, that's why this area is changing, isn't it? No, theta C is a constant. H is changing. Yes, it will depend on H. It will depend on H. Yeah, see, it is depending on H. As H, isn't it? It is depending on H. dA dt is depending on H. But the extreme rays will still have to make theta C. Extreme rays will still have to make theta C. Isn't it? Got me? These are two equilateral prisms. And made of material of mu equal to root 3, both these prisms. Now a ray of light incident on this prism, say incident at an angle I, suffers minimum deviation, That means if this is I, this must also be I. If this is R, then this must also be R. For minimum deviation, yes, I equal to I prime and R equal to R prime. Minimum deviation. R plus R must be 60 degrees. Must be equal to the angle of the prism. 2R is 60 degrees. So R must be 30 degrees. right? R plus R prime is the angle of the prism. So in this case R is R prime. So 2R is 60 degrees, R is 30 degrees. And I can find I by applying Snell's law here. So sine I is root 3 sine 30 degrees sine R. So I must be 60 degrees, root 3 by 2. I must be 60 degrees. Yes or no? Right? Now, the deviation produced by this prism is going to be I plus I prime minus angle of the prism. I and I prime are 60 degrees. A is also 60 degrees. So this is 60 degrees. Is the deviation produced by the prism? Right? Now, that's one. This ray, emergent ray, is incident on this prism. What we want to be able to do is, we want to be able to rotate this prism about C. We want to be able to rotate this prism about C such that this ray also undergoes minimum deviation through this prism. You know what I'm saying? That means this ray must also be incident at an angle of incidence 60 degrees on this prism so that it can undergo minimum deviation on this prism, right? Right? Now, ordinary geometry, very ordinary geometry. See, this is the first prism, right? This is an incident ray. Emergent ray, and the angle between the incident ray and the emergent ray, this is the emergent ray, this is 60 degrees, This is what it means. If the deviation is 60 degrees, that means if you produce the emergent ray, nothing had happened to the incident ray, it would have traveled in this direction. But now, because of the prism, it travels in this direction. So that means it must have got rotated by an amount equal to the deviation, which is 60 degrees. Angle between the incident ray, which is this direction, and emergent ray, which is this direction. This is what the prism did. The prism rotated the incident ray, which would have traveled like this, by an amount 60 degrees, so that this becomes the final direction of the emergent ray. Yes or no? How many of you don't understand this fact? You want me to I'll repeat. See, if this is an incident ray and if this is an emergent ray, incident ray, right? And in between the two, there is the prism which has caused two refractions. What did the prism do in effect? The prism, if the prism was not there, the ray would have gone this way. If the prism was not there, the ray would have traveled like this. But now, because of the prism, the ray is traveling this way. That means, what did the prism do? The prism, instead of letting it go this way, it made it go this way. That means it caused an angular deviation of the ray, which is the delta produced by the prism, which must be 60 degrees. This is what the prism did. Right? Now, having said this, so far so good, right? This angle is 60 degrees, angle of incidence, right? Is 60 degrees. This angle of incidence is 60 degrees. Now, the ray, this emergent ray, this ray got rotated by 60 degrees, this incident ray got rotated by 60 degrees, so that this became the emergent ray. Yes or no? So think of it in C2 only. This was the incident ray. What did the prism do? The prism rotated it clockwise by 60 degrees, so that this became the final direction. That means the prism produced an emergent ray which was like this after rotating by 60 degrees. That means this emergent ray must have been perpendicular to this face, yes or no? I'll repeat now. I'll tell you. This is the emergent ray, this is the incident ray. Right? What did the prism do? The prism rotated this by 60 degrees to get this direction. Now rotate this right here by 60 degrees. Then it will be like this. That means it will be perpendicular to this face. That means this emergent ray must have been perpendicular to this face. This is what it means. I can repeat one more time. I'll repeat. The prism rotated the incident ray by 60 degrees. That means, what did the prism do? If this was the direction of the incident ray, this was already 60 degrees, right? What did the prism do? The prism produced an emergent ray which was rotated by 60 degrees like this. That means it produced an emergent ray which was perpendicular to the first face. That means this ray must have been perpendicular to this face, yes or no? Right? Which means what? See, if this ray is perpendicular to this face, then this ray will also be perpendicular to this face. Why? Because these two faces are parallel to each other. That means this emergent ray is incident normally. That means angle of incidence is 0. Right? Got me, no? That means this ray is incident normally on this prism. That means angle of incidence is 0. But how much is the angle of incidence that you need on this face? 60 degrees. So you rotate the prism instead by 60 degrees. So rotate the prism in any sense. You could rotate the prism in this sense by 60 degrees so that the angle of incidence, which is 0 here, can become 60 degrees. So rotate the second prism by 60 degrees so that the angle of incidence here can become 60 degrees. And you would get minimum deviation out of the second prism. Any sense. Any sense you can rotate. It's an equilateral prism. In one sense, this will be the angle of the prism, or this could become the... It will not matter. Got me? Is that okay? Sorry? How I got 60 degrees?
Because it has to be incidented at 60 degrees, right? So you have to move it by 30 degrees to make that angle 60 degrees.
Really? Angle of incidence is 0 degrees. You will have to rotate it by 60 degrees only. Siddhant. Clear? So then problem 8. There is an equiconvex lens, glass lens, with radius of each face r, right? Magnitude of the radius of each face is r. Mu of glass with respect to air is 3/2. There is water in object space. There is water with mu w, everything with respect to air, so might as well remove this, equal to 4/3. This is the object space. The object space is not where the object lies. Is where, right. And air in the image space, where the final refracted ray lies. Image space. Air. Mu equal to 1. We want to find the focal length of the lens. We want to find the focal length of the lens. Clear? In terms of r. which means you would imagine a ray coming from infinity, u equal to infinity. We want to see the point where the final image of this is formed, that will be the focal length. The final image of this object at infinity will give me the focal length of the lens, right? Okay. So u is infinity. Let me find, there would be an image formed by this, and that image will serve as a virtual object for this, and then a second refraction would result in a final image which would be the focus, which would be the focus of the system. What do you say? Right? No, very thin lens, yaar. What is up? No, that's a special ray which when passes through the optical center. Thin lens, there still are two refractions on the thin lens. Lens thin or thick, there would be two refractions. We used thin lens because, you know, then whether I measure from here or measure from here or measure these distances from here, that will not make a difference if it's a thin lens. Right? Thin lens doesn't mean there would be one refraction. A lens would always be about two refractions, thin or thick. Okay? So, let's say refraction on first surface. This will be the image space and this will be the object space. For refraction on this surface, this would be the image space and this would be the object space, right? Image space refractive index by image distance v1, which is the image formed by this, right? Minus object space refractive index by object distance infinity is difference in the two refractive indices 3 by 2 minus 4 by 3 divided by the radius of curvature. Now, the center of this surface lies on this direction. So, I'll use minus r divided by the radius of curvature. So, it's going to be minus r. Right? Now, this V1, wherever it is, will be a virtual object for second refraction. And let's say V is where the final image is formed. V1 would be the object distance for refraction on this surface, and wherever the image of V1 is formed will be the focus, right? So, then refraction on second surface. Now, for refraction on second surface, this will become the object space and this will become the image space. So, image space refractive index by final image distance V, which will also give me the focal length of the system. Image space refractive index by final image distance V minus object space refractive index, which is 3 by 2 divided by V1 object distance is difference in the two refractive indices. 1 minus 3 by 2 means minus half divided by r, right? Because the center of this lies in this direction, measured opposite to the direction of the incident ray, so plus r. You don't need V1. This will become 0. 4 by 3 by infinity will become 0. This will be 0. If you add these two equations, you can solve for V. And this V will give me the focal length. This V will give me the focal length of this system. Add these two equations and you will get V. Right? Last class bunked. Why? Huh? Is that okay? Right, so this system of pulleys as shown, and this moves down these two pulleys move down with a velocity v naught, like an object, right? Convex mirror of radius of curvature r. We want to find the velocity of the image. But before that, we'll have to find the velocity of the object at least. Now, if you have done the string constraints right, then you should be able to say that this would be 2v naught by cos theta, right? This will be the velocity of the object. It's going to be upwards. Yeah, it's going to be. This is going down, this upwards. 2v naught by cos theta. You have to go back to my mechanics classes to register this, in case you've forgotten. Right? Now, at any given instant of time, then, if x is the object distance and v is the image distance, then 1 by v plus 1 by u. V is the algebraic image distance, 1 by u means 1 by x. X is positive here, is 2 by r. I'll use minus r because r is measured in this direction. Right? So, this is v1, the velocity of the object. This is v1, the velocity of the object. Clear? So, image distance v, 1 by v, is given by minus 2 by r minus 1 by x. V is then given by minus rx divided by 2x plus r. V is the image distance when the object distance is x. Right? Rate of change of this will give me the velocity of the image. Rate of change of this will give me the velocity of the image. Right? So, dv dt is what we are seeking. And do you realize that dx dt is v1, which is 2v naught by cos theta? Velocity of the object, dx dt. Clear? So let me differentiate this with respect to time. Minus r I take common. Derivative of this with respect to time will give me v1. Dx dt will give me v1 into 2x plus r. Right? Minus 2 times derivative of denominator dx dt will again give me v1 into x, derivative of numerator into denominator minus derivative of denominator into numerator divided by denominator squared. Right? See, 2v1x and 2v1x will get cancelled. All that we are left with is minus r squared v1 by 2x plus r whole square.
So won't V1 also be a variable?
Hmm?
V1 will also be,
At this instant.
so at all instances, because cos theta will be changing at all.
Yeah, but I'm talking of at a given instant when theta is theta. Yeah, so it will be variable. Sorry? M square?
That was derived like this.
This only. You could have differentiated minus 1 by v squared minus 1 by x squared is 0. But then in that you will have to plug in the value of v, right? So v you will still have to obtain from this equation, and there is no pain differentiating a numerator by denominator, right? In any case, you would have had to plug in the value of v in that expression also, sourcing it from here. So the number of stages are the same, right? And v1 you can plug in as 2v naught by cos theta, and that's going to give you the velocity of the image, right? See, in geometrical optics, they have an uncanny knack of, making the object move, the mirror move, and therefore look at the response of the image to the motion of the object and the mirror. My first class where I dealt with the plane mirror moving in various ways, the object moving in various ways, and you know, the response of the image to the motion of the object as well as the image, right? Those were the things that were looked into. So are you discharged, or there is some charge left in you? Some charge left in you. Can I quickly discuss one more thing? Mirrors inclined to each other. It will not take us very long, right? Stand by.